Next, we're going to start talking about the binomial theorem, which is the big idea from this section. Now, when you look in your book or you look at the Help Me Solve This, the binomial theorem, there's a formula and it looks scary. It has summation notation and a bunch of letters on it, and it looks really complicated, but the truth is it's very easy. It's just about a pattern. So what we're going to do is we're going to look at the pattern. So first, let's review what is a binomial. A binomial is a monomial with two terms. Okay, so I'm going to start with just a plus b. And I'm going to do this in a systematic way. I'm going to start by raising it to the 0 power, which I know seems silly, but that's where the pattern starts. So anything to the 0 power is just 1, so that's 1. That was boring. Okay, let's do the next one. A plus b raised to the first power. Well, that'll just be a plus b. Okay, that's interesting. Next, a plus b quantity squared. Now we know this one. You know you're supposed to FOIL stuff out, right? Multiply it, and what we end up with is a squared plus 2ab plus b squared. Okay, that's interesting. Now let's do a plus b to the third. Now before, if you wanted to figure out what a plus b to the third was, you would have to do the a plus b squared and get this answer. And now take this answer and multiply through by the a plus b and do maybe multiplication with in the vertical format, if you remember from way back when, and you get this long old thing you got to gather like terms. Okay. The binomial theorem gives us the pattern to do it without actually multiplying. So, since I know what the binomial theorem is, I know that the answer will be a to the third plus 3a squared b plus 3ab squared plus b to the third. Interesting. Okay, let's do a plus b to the fourth. Okay, again, before we would have to multiply a bunch of stuff out. It would take a long time. There would be a lot of terms. Maybe you'd screw something up. Okay, so if you know the pattern from the binomial theorem, you automatically will know that the answer is a to the fourth plus 4a to the third b. Notice that will be b to the 1, plus 6a to the second, b to the second, plus 4a, that'll be to the 1, b to the third, plus, oh, you're not going to be able to see it, b to the fourth. B to the fourth. Interesting. Okay, so let's look at this pattern for a moment. The first thing I want you to notice is whatever the exponent was on my binomial, there is one more term than that. See, when the exponent was 4, I have 5 terms in my answer. Okay, I also want you to notice that the way it starts is, it starts with a to the fourth and there is no b. Notice, if there's no b, we can think about it as being b to the 0 hidden here, can't we? So it's like a to the fourth, b to the 0, because we know b to the 0 is just 1. Then the exponent on a goes down by 1, and the exponent on b goes up by 1 for each term as we go, until we get b to the fourth, which is where we have to stop because that was the original exponent. Then the coefficients on each of these terms come directly from, hey look, Pascal's triangle. And if you compare the two, you will see that the coefficients from Pascal's triangle match the coefficients on these terms. Okay, so I'm going to pause and we'll do some problems from the worksheet. Now I'd like you to look at your worksheet, and I'm going to do my work on a separate piece of paper. I'm looking at number 4 from your section 8.5 worksheet. And we're now going to use that pattern to expand 5x minus 5y quantity raised to the third power. But I want you to notice that in this, A is equal to 5x, that's the first term, and B is negative 5y. The binomial theorem had A plus B in it to find our general pattern, so take the sign in front of each of these terms. Okay, now, since this is to the third, I know that the general pattern, and this is a good idea to either practice or look back at the notes from before, A plus B to the third power was A to the third plus, and then you look at Pascal's triangle, and it's the row that has 4 terms on it. So the next one will be 3a squared b to the 1 plus 3a to the 1 b squared plus b to the third. Okay, that is the general pattern for a plus b to the third. So now what I'm going to do is I'm going to substitute. Instead of a, I'm going to put 5x, and instead of b, I'm going to put negative 5y. Okay, so I will get that 5x minus 5y raised to the third power is equal to 5x raised to the third power, don't forget to put it in parentheses, plus 3 times 5x raised to the second power times what was b? Negative 5y, plus 3 times 5x, negative 5y raised to the second power, plus negative 5y raised to the third power. And now I go through and use your rules of exponents and multiply and simplify everything. And I'm going to do that and then show you the answer. So there is my final answer. I've used my exponent rules and I have multiplied. Watch your positive and negative signs. And there's the final answer. Okay, now let's do another one. Let's do number 5. So number 5 is 3x plus 5 raised to the 4th power. So I'm going to skip that step and I'm just going to look over at my old notes. And I know it's going to start with a raised to the 4th power. Then I'm going to have plus. Now when I look over at Pascal's triangle, okay, so this is the row that has 5 terms. Okay, so the next number will be 4. And then I'll have a raised to the 3rd power and b raised to the 1 power, right? Okay, plus, I better write smaller. I'm going to run out of room. The next coefficient will be 6, a squared b squared, plus 4, a to the 1, b to the 3rd. Oh no! And now, one more, plus b to the 4th. Okay, b to the 4th. Now, what am I going to fill all those parentheses in with? Well, let's look back over here. My first term a will be 3x, and my second term b will be 5. So I fill in, that's really 3x to the 4th, plus 4 times 3x to the 3rd, and what was b? 5 to the 1. Then 6, 3x, and then this was 5. The first parenthesis is 3x, the second parenthesis is 5, and then this last parenthesis is 5. Okay, so you see how you use the general pattern from the binomial theorem, and then you substitute. Now again, go through, use your rules of exponents, multiply, and I will write the final answer here. There's my final answer after I simplified everything. So you go through that, make sure you get the same thing. And I'll let you guys do number 6. Let's see, did we go down that far in our Pascal's triangle? We did on our previous notes. We have the right row of coefficients that you need for number 6. So try number 6 on your own and then check it against the answer key I handed out in class. Okay. Now, when you do 7, 8, and 9, please read them very carefully. 7 just says find the first 3 terms. You don't have to find the whole thing. You can if you want, but you don't have to. And 8 and 9 are asking you to figure out what a particular term is. So what I would do is I would kind of write out the general pattern and then count to find the 8th term. So for example, on number